This is part 7 of the rational functions videos. In this video, we are going to learn how to find horizontal asymptotes of rational functions. So a horizontal asymptote is kind of like a vertical asymptote. It is a line that the function is undefined at or cannot touch or cross, but it is written as y equals a number. Because it is a horizontal line, we write it as y equals, and then whatever number it happens to be at. The weird thing about horizontal asymptotes is graphically, they only um, affect parts of the graph. So when we look into graphing, horizontal asymptotes do have that special property where you might have parts of your graph that do cross them. For horizontal asymptotes, we are going to use the unfactored equation. So this is different than what we've been doing. Normally, we want to simplify our equation and factor it and simplify. For this, we don't have to. We can look at the unfactored equation. So here I have our unfactored equation. Now, the second step is going to be to compare the biggest exponents or the degree of the top and bottom of the um, function, so of the fraction here. So we are going to look at the biggest exponents. So here my biggest exponent is 2, and here my biggest exponent is 2. So that would mean that both exponents are the same. The next step is we're going to follow these 3 rules. So there's 3 rules. We can either have the exponents be the same, the exponent could be bigger on top, or the exponent could be bigger on the bottom. Those are the only 3 cases you'll ever get. There are some acronyms that can help you remember these rules. So the first one is BOBO, which means bigger on bottom, y equals 0. So if your exponent is bigger on bottom, you don't have to do any type of computation. You would just write y equals 0. The next one is asymptote is bigger on if your exponent is bigger on top, you would have no horizontal asymptote. Um, we'll talk later about different types of asymptotes you can have. In this case, it would mean that there is a slant asymptote. But all you need to know is if the exponent is bigger on top, that means there is no asymptote. And we use botno to help us remember that. The last one, this might be difficult to remember, eats DC. It means exponents are the same divide coefficients. So that is the one that we have. Our exponents were the same. So we would want to divide the coefficients. So since we don't have any numbers in front of x, because keep in mind, a coefficient is the number in front of the x value, it would be 1 over 1. And so that would mean that our horizontal asymptote is y equals 1. So I have a couple other examples that we can look at here. Um, remember the rules. If it's bigger on bottom, y equals 0. If it's bigger on top, there's no horizontal asymptote. And if the exponents are the same, we divide the coefficients. So let's take a look at this first example. On top, we don't have an exponent next to this x, so that means the exponent is 1. And on bottom, our exponent is 2. So our exponent is bigger on bottom, so bigger on bottom, y equals 0. So y equals 0 is our answer for number 1. For number 2, when we compare the exponents, our biggest exponent is 2 on top. Once again, we have x to the first on bottom. So it is bigger on top now. Bigger on top means that there is no horizontal asymptote. So you would write no horizontal asymptote or none. And then our last one, so here on top we have x to the first, and on bottom we have x to the first. So since they are equal, we are going to divide the coefficients. So on top, the number in front of x is 2. On bottom, the number in front of x is 1. So when we divide 2 divided by 1, we get y equals 2. And that is how you find horizontal asymptotes.